Alright, hello everyone, welcome back. So the purpose of this video now is just to introduce categorical predictors into a regression model. And so far everything that we've talked about, we've had a quantitative response, course score, for example, and we've had a quantitative predictor, which for the example in the note packet has been attractiveness. And so now we're going to cover this last topic in regression, which is going to be, well, what if the predictor variable that we want to include is categorical, not quantitative? And so sticking with the course evaluation data, we're going to use the course score still as our response variable, but now instead of using attractiveness, we're going to use gender as a predictor. And so for the purposes of this example, we're just treating gender as binary, even though that's not really accurate of the real world nowadays. But for this example where we collected data, the data that we collected had gender as a binary variable, so either female or male. And so on this plot, each point kind of represents a different course, and so the points are kind of spread out here, but these are all the course scores for the females and all the course scores for the males. A graph that we're probably a little bit more familiar with looking at this type of data would be our side-by-side box plot. And so that would look something like this. With score on the y-axis, we'd have a plot for female and a plot for male. So something like that. And so in order to build this regression model, we're going to have to convert this categorical variable of female and male to a numeric variable. And you might take a second to pause the video and ask yourself, well, why would we have to do that? Okay, so the reason we have to convert male and female to a numeric variable is because eventually when we have this fitted regression equation, we're going to be like adding and multiplying and doing all that mathy stuff. It doesn't make sense to multiply, for example, male by 0.1415 because male isn't a number. Like you can't like multiply computer by 5. It just doesn't really make any sense. And so in order to convert our categorical variable to a numeric variable, we're defining this indicator variable, which is just a variable that takes on either a 0 or a 1. So for this example, I'm going to define this gender indicator variable, which I'm going to call gender ind. So ind stands for indicator. And I'm going to let this variable be a 1 if the professor is male, and a 0 if the professor is female. Alright, and so why I gave the 1 to the males and the 0 to the females is just because I want it to match up with the output that we're getting from R. So how I decided really isn't that important. We're not going to focus on that, but we're giving the males 1, females 0. Then if we use this indicator variable to get some summary output in R, let's go ahead and see how we're going to generate predictions for course score just based on the gender of the professor. And so let's go ahead and start by writing this fitted regression equation. And so this is super similar to what we did before. So the fitted regression equation, 4.093 is the intercept, and then 0.1415 is the slope that we're going to multiply our gender indicator variable with. So just as a reminder, this was defined above, and it can only be a 0 or a 1. Okay, and so then using this equation, let's predict the course score of a female professor. And so this also ends up being the mean score for female teachers. And so when I do this prediction, remember what we did before was we just plugged in a value for x here. We're doing the same exact thing. All I'm going to do, so no need to make this super complicated, all I'm going to do is come back up to my gender indicator variable. I know that I'm predicting for a female teacher, so therefore I'm plugging in a 0 for that gender indicator. So our prediction for the mean score for female teachers is 4.093 points. We could do the same thing for male teachers, or male professors. Now when I go to plug in x, I go back to where I defined the indicator, and I see that, okay, if the professor is male, the indicator is a 1, so I'm going to plug in a 1. And if you do that calculation, you should get 4.2345 points. So this first thing is the mean for female professors. And then our second calculation is the mean for male professors. Okay. And so if we interpret the intercept here, this 4.093, all that is the mean for female professors. So my interpretation could just be something like for female professors, we expect the average course score to be 4.093 points. So in general then, you might be able to see a pattern with what the intercept is always going to be if we have a categorical predictor. In general, this is just the average response for the level of the categorical variable that got the 0. So in general, it's just going to be the average response for whatever category ended up with the 0 in your indicator variable. All right, so we could also interpret the slope, which is 0.1415. And I'm just going to rewrite what the mean for females is and the mean for males. And so you might notice that, okay, all this slope is the difference between these two groups. And so when I interpret it, I might say something like, well, we expect the average course score for males to be, since it's the difference between the two groups, I'm going to say to be between 0.1415 points higher than the average score for females. We could also write a general interpretation that this is going to be the average response for the one group, so whatever group got the 1 in our indicator variable, minus the average response for the 0 group. Okay, so these indicator variables, they are a little bit difficult to get used to them, but once you do, you'll see they're really not that bad. It's just a 1 and a 0, and so that's just always what we're plugging in for our x when we do predictions for the two categories. And then this slope is always going to represent the difference between the two categories that we're talking about. And so it's always going to be the category that got the 1 minus the average for the category that got the 0. Okay, so next time we'll pick up with this with the hypothesis test, and then we'll finish off with a confidence interval for the slope as well.